Alright, so 2BD pre-calc class. Hopefully you guys came with some observed data from the lunches, and you can put your numbers together and tell me how many out of how many observations you have, and then create a percent here. So take a moment to do that, please. So for example, in my AC class, they only collected 35 observations. They said there was an issue with the fire drill. Oh, they went off. So I believe them. Anyway, they got 22 out of 35, or 63% of the water milk containers to be recycled. So you fill in your numbers here, okay? And then we're going to create a simulation. So what I'm going to have you guys do is take a spinner. So Mrs. Bird had the spinners for you. You'll need a paper clip, and you'll need 2 pieces of tape to tape it on there. And we're going to assume that 75% of the containers are recycled, because that was Mr. Gasparini's threshold. We're going to spin how many times? Well, my other class, they needed to spin 35 times because they had 35 observations in their sample. You'll have some other number, probably. So spin it that many times, and then create a sampling distribution of the sample proportions. So each group should be 2 of them, and if you can figure out how to get the smiley face up there, you're going to click on the, maybe I can kind of show how that works here. You're going to come up here and click on pen, and then creative pen, and then get smiley face. Then you can make smiley faces at your particular proportions, whatever you get from your simulation with the spinner. You should each do 2 per group. So I should see 2 proportions per group. They may be the same or they may be different. So why don't you pause this recording and get everyone to record 2 different simulations. Okay, so hopefully you took time to work that out. I would like you to put this graph, this dot plot, into your notes. And it should look something like this. Here's the one from my BD day class, or my AC, excuse me. They had something like this. You can see it's kind of centered around 0.75, but there's not enough trials here to really see a nice bell curve. And yours is probably something similar. I don't know what your proportion is, but in their case, it was right here. It was at 0.63. So we were looking at that number and saying, oh, is that unusual to see a 0.63? And it kind of looked like it was. Didn't seem very common, but we needed to do more trials. So I want you to get out your applet, okay, and you can do this on your phone if you like, or if the cart is in your classroom, go ahead and get onto rossmanchance.com, isiapplets.html. I want you to set it up to run a simulation of 0.75 as our probability of success, and then whatever your number of trials is. So in our case, it was 35 in the AC class. Do whatever yours is, and run at least 100 trials, but you could do a lot more than that if you like. So let me have you pause this recording and go ahead and carry out that simulation. Okay, so hopefully you carried out that simulation. I'm guessing it looks something like the one from my other class. And if you do enough trials, I've got 500 trials here, you're going to see somewhat of a bell curve. You should click Summary Statistics so we see the mean and the standard deviation of the sampling distribution. I want you to look at where your class's proportion of success came out from that sample that your classmates collected. Again, in my AC class, it was 63%. So we looked at this and we said, is that unusual? And if I were there asking you, I would probably ask you to vote with your thumbs. And in this case, the 0.63 is kind of right on the edge. It's not really common. It's not like a 0.69, but it's not way down here like a 0.5 either. It's a little bit unusual, but not super unusual. So one way we could quantify this would be to go out and find out what are 2 standard deviations below the mean. We kind of did this in our homework, right? So for my particular numbers here, I'm going to start at the mean and subtract 2 standard deviations. And I came up with 0.063. So because 0.63 is within 2 standard deviations, we don't consider it to be significant. It needs to be really strange, really unlikely, like out here, to be considered significant. So your conclusion might be similar, or it might be different. You might have a number that's outside 2 standard deviations, be something that's pretty unusual. So now we have a little choose your own adventure. You have to kind of decide how your answer compares to what the other class had. If you have a number that happened fairly frequently, this would be your similar conclusion. Even though our sample proportion of 0.63 was much lower than 0.75, it's not statistically significant. Oops. It occurred somewhat frequently in the dot plot, right? Kind of happened a bit. It's kind of on the edge. If on your test or your Regents you said it didn't happen very much in the dot plot, I think we'd accept that for that particular situation as well. But we could proceed to find 2 standard deviations below the mean, and because it's within 2 standard deviations from the mean, it's considered to be likely. So what do we conclude about Mr. Gasparini? Well, because it's within 2 standard deviations, we say we're not super surprised by that. It's not significant. Mr. Gasparini should not initiate a recycling campaign. It's possible that 75% of the containers are being recycled, and we just happen to have a sample that was a little on the low side. However, if your class got a value that was down here, that was outside 2 standard deviations, that was really rare, like 0.5, then you would have a different conclusion. You would say it is statistically significant because it hardly ever occurred in the dot plot. You would say, furthermore, your value of, like, let's say 0.5 is beyond 2 standard deviations from the mean, so it's unlikely. And then your conclusion would be, wow, Mr. Gasparini should initiate a recycling campaign. It is not possible, based on our sample, that 75% of the containers are being recycled. It's much less than that. Okay? Give you a second to write down stuff. If you're having trouble with writing these conclusions, don't worry. We have another day where we're going to continue to work on the conclusions that we make from our simulations. So be patient with yourself, and I'll get back with you next week. We'll get it all figured out.